Hi, welcome. You have gone through week 1 of C and you've covered a little bit of some C syntax and you got quite used to the basic C syntax and some of the header files that you may be inputting quite a lot of times. So now we're going to be doing a little bit of some revision and working through a little bit of some problems. But let's go through a little bit of some theory work to begin with first. So when we're getting started with C, we realize that C is a low-level programming language. What do we mean by C being a low-level programming language? We just certainly meaning that you write code in C and it communicates directly to the CPU. It's pretty low level. You do not have some sort of gateway that you need to pass through or some interpreter in this case. So it's pretty direct. So you have to write some code, compile it, and that code will essentially give instructions to the CPU on what to do. All C files must end with the extension .c. For instance, if I was to write a script called hello, then I would have to call it hello.c. And this is the whole idea of file extensions. We have to add the .c towards the end of the name of the file. Just like how we would have images being .png or .jpg or .jpeg, and text files being .doc, and so on and so forth, or .txt. C files will have .c at the end. This is how the PC is then going to familiarize itself with the type of file that is there. C contains source code. So your C file is going to have what is known as source code. So C files contain source code. However, the computer does not understand it. Therefore, we rely on compilers to translate it into something understandable. So if you recall, we had the idea of source code and machine code. The source code, this is what I put into the C file, the int main voids and all those kind of stuff. And then I'm going to essentially compile this into machine code. And machine code is what I'm going to then execute, or what the computer is going to open and run. That is my program. C uses a compiler to transform the source code into machine code, as I've mentioned. Remember, the machine code is the readable data. Compilation consists of multiple steps, which you're going to learn in one of the upcoming weeks what those steps are. However, we use the command make to automate pretty much everything that is performed during the compilation process for us. After compilation, binary or machine code is going to then be created. We're going to see this as we go through some practice problems. We noticed when we're using an IDE like Visual Studio Code or the CS50 IDE, we had something called the terminal. And the terminal is something that you have to be very familiar with at this point. Changing into and out of directories in this terminal is something that you must be a master in at this point in time. Remember, a directory is a folder. You're going to hear that word a lot of times. A directory path refers to all the folders that you get into in order to get to the folder that you are in. I'm going to show you an example after this. Windows and Linux have similar environments, but computer scientists and IT technicians will always prefer to use a Linux shell instead rather than a Windows one, due to the limitations that Windows comes with. But nonetheless, at this point in time, you should be quite familiar with the CS50 IDE, and we're going to take a look at it. And then we looked at some of the basic syntax using C, and this is basically everything we begin with first. So hashtag includes standard io.h or stdio.h in short, and then we declare the main function, which is the int main void, and then we open and close the curly brace, and then all our source code is going to be right in between those two curly braces. And we looked at some of the beginning parts of it, like displaying text on the screen in C. Let's take a look at this. We're going to go over to the CS50 IDE, and that's ide.cs50.io, like so. So if you remember, we used the CS50 IDE just for doing some of the practice problems, and then we used the VS Code in order to basically do our actual problems, which was the problem sets and the lab assignment. So we're going to use the CS50 IDE now, just for the sake of practice. So I'm logged in to my GitHub account at this point in time. So it will not prompt me to log into my GitHub account. But that's the idea. So happy coding, right on cloud 9. So here's my IDE. I'm just going to get rid of most of the stuff just so we start off afresh. I'm just going to delete this. And then let's start afresh. So this is our code editor. This is where we're going to write our code. And this is the terminal. This is what we're going to perform the navigation with. And then towards the left right there, that's just a file explorer. Not as fancy, but nonetheless, this was the terminal that we're speaking about. You have to be quite familiar with using the terminal. So what are the basics of using a terminal? Well, first things first, you need to know where you are. Using the command pwd, it will show you where exactly you are. You're in home, in the Ubuntu directory. And then the next that you need to know is the ls. The ls is used to list the files that are in the current folder that you're in. Note, after running pwd, it showed me that I'm in this folder at this point in time. ls, however, gave me nothing. That's just to show that this directory path is empty. Remember, this whole thing is a directory path. What am I saying? Well, what I'm saying is I'm in a folder called home, and inside that folder called home, there is another folder called Ubuntu, and that's where I am. Nonetheless, proceeding. Then the next command you have to know is mkdir. This is used to create a folder. So let's create a folder called practice. You'll notice that on the left there's a folder that just got created called practice. So inside that folder you can notice that it's pretty empty. There's nothing in there. So where am I right now? I'm still in the very same place, but now I would like to go into that folder. So note once again, if I run ls, I'm gonna see practice. So let's get into practice. So I'm gonna cd into practice. This puts me into the practice folder. Remember pwd, which shows you where you are? If I run it, you can see inside the folder called home, there's another folder called Ubuntu. Inside the folder Ubuntu, there's a folder called practice, and that's where I am. That is the mere basics. What else do I need to know? Well, touch. Touch is used to create an empty file. Suppose I would like to create a file called file.c, for instance. I touched it. I created it. It's empty. If I run ls, you'll notice that there's now file.c. It's an empty file per se. How do I open the file? Well, in the file explorer, it's right there. I can pretty much double click it, and then it's open. Note, when you're working with C files, make sure that all the configuration is correct. You should be able to see here. It has to tell you that this is C or C++. But that's the idea. So that's the concept. What if I want to get rid of that file? I can merely go there and just delete it, or I can remove the file. rm, I can rm file.c. Do I want to remove this file? Yes. Like so. Now it's gone if you look in the left panel there. But that's the whole case in point and the idea. So we were looking at how to display text, how to show words or anything within the terminal. And if you look back there, it is said that we're going to make use of the printf function to do this. Functions always have open brackets. Like the printf, it has open brackets. And this is the format. Printf and the content to show. But before we do that, we need the basic template. So let's begin with a hello world problem. So I'm going to first begin by touching the file. I'm going to first begin by touching hello. And then note I have to add the .c. Here's hello.c. Note that it has to tell you the language. Nonetheless, now remember to first include your standard io.h. This is your header file. If you do not have the header file, then you cannot print anything. You cannot use the printf. Then I'm going to declare my main function. what is the main function all about? Well, the main function is just telling me where does my code start and end. The moment this program executes, the moment this entire app of mine starts, everything in here is what's going to be executed. That's the idea. And then we said, that's the basic. At this point in time, this program does nothing because I've put nothing inside my main function. But let's put some stuff into it. We said printf is used to show some text. So let's show some text. I'm going to say printf. Why am I using open brackets? Because it's a function. And then I'm going to put some quotations for some words that I would like to show. What would I like to show? Something like so. And then remember, a semicolon at the end whenever you call a function. Now that I have it like so, I need to save this. So Control S to save. This will save everything. So you can Control S or go over to File and Save. Note it's also Control S. Now that it has been saved, I'll go back to the terminal. Note if I run ls, I'm only going to see my hello.c file, like so. Moreover, I need to compile this. I cannot run this with my program, with my PC. Note if I say hello.c, it's not gonna do anything. This cannot run. I want to show you something a little useful too. The file command. If you don't know what type of a file it is, you can use the file command. So let's say I don't know what hello.c is. So I can say file hello.c. And this tells me that this is a C source file. Pretty safe, pretty decent. Nonetheless, now let's run this hello.c. To do this, we need to compile. So to compile, we're going to run make. We're going to make hello. I don't need the .c, it's just hello. I got no errors. But if I run ls this time, notice before I just had hello.c, but this time I have hello and hello.c. The hello, which is highlighted in green here, this is what I can run. So how do I run it? Well, you can go around doing that and say open, you see, which will not open in your text editor, unfortunately, because this is binary. It cannot open. So to do this, you're gonna need to say / and then the name of the file, which is hello, like so, and it says something, which is pretty much what we wanted to display. But we saw that there's an issue. The practice prompt came immediately after the something. So we need to place in an empty line. We're going to place in a new line immediately right after that. Now, should I run it again? Well, if I run it, it will show me exactly the same thing. But I just made some changes. So what do I need to do? I need to compile it. I need to make it again, just so it brings the new changes to the whole binary. So / hello something on a new line this time. So now we know how to display all those things in how to display text using the printf function. But now the next piece is variables. We kept in mind that we can store data, we can store information using variables. A variable is just a container. Keep that in mind. It's just a container. Imagine you have a box that you're able to keep something in it, and then somewhere in the code you're able to unpack that box, and then you use the contents that are within that box. That's what we're going to do. So we're going to make use of variables now. So let's just suppose I was performing the hello problem, and if you recall the hello world problem, just started off like this, and then I'm able to make this to make hello, which pretty much compiles perfectly, and I can say / hello, which gives me my hello world. Nothing fancy, but perhaps I would like to use a variable. Let's get the concept, the basics of variables entirely. When you are creating a variable, this is what you need to keep in mind. Variables are used to store information, but to declare a variable, you have to first note of its data type. What do we mean by data type? Well, you have to keep in mind, what are you trying to store within this variable? Is it a number? Is it a word? Is it a single character? Is it a decimal? Is it a very long number? What is it exactly? So let's review the remaining things. When you call back a variable, you're going to use its name. So whenever I need to use this variable, I'm just going to say it by name, its variable name. Alright, let's try that out. So let's just suppose I'm going to create an integer, a whole number, I say. So I'm going to create an integer. I'm going to create a variable called a and maybe put in a number like 12, for instance. So I cannot say a is equals to 12. This is incorrect. I have to tell C what type of data type 12 is. So I have to declare that this is an integer called a. Okay? If you go back here, you'll notice that there are two ways of declaring variables. You can declare a variable in this form. You can give the data type and the name of the variable. This is to create a variable that is unassigned. This is a variable that has no value, like this. This value of a of ours has no value to it. There is nothing inside a. This is to create an unassigned variable. Another way to do this is by giving the data type, the variable name, and an equal sign, and then giving it a value. This is to assign it and create a variable at the same time. So instead of saying int a, I can rather go in and say int a is equals to 12. Now I've created the variable and given it a value. As opposed to the previous way where I would have done this, I create a variable and not assign anything, then I can later on assign it. This is okay. But it can all be summarized by just doing this. But let's suppose I create a variable a, that's how I do it, and assign 12 to it. And then I can create another variable b, and perhaps assign, I don't know, maybe a 13 to it. What if I would like to assign another variable called c? Well, I do it like that. This is c, unassigned. And then let's say maybe I would like to assign a plus b to it. I can do literally just, you should be quite used to, something like this. C will basically be 12 plus 13. But keep in mind that I cannot have the assignment after. This becomes incorrect. Because at this point in time, when it gets to this line, it does not know what is b. So you always need to initialize your variables first before using them. Note that I've called them by name to call back that variable. Okay. Note as well, preceding this, when you are using printf with a variable, what do I mean? Where I'm saying, when you're trying to display a variable's content in a printf statement, we have to use a format specifier, and this is based on its data type. So let's just imagine I would like to run printf, and then I would like printf, remember printf is used to display stuff, and I would like to print what is inside the C. Well, I cannot say print C, otherwise this will literally say C, but I want to show what is inside C. To do this, I need to use a format specifier, the %i. I said %i because this is an integer that I want to put here. Think of it as a placeholder of some sort. So there's my format specifier, and then after the quotation here, I'm going to put in a comma, and then I'm going to put in the variable that I would like to place within that %i. And it is C in this case, and then I'm going to close it off like so. If I save this, remember C is just a plus b, so it should be able to go within that %i. And note that C itself is casted as an integer. So if I run make hello again, then I run hello, I get 25, which is 12 plus 13. But once again, this sort of wraps onto one line with the prompt again. So I may, by good habits, want to use the new line to my advantage. If I run make hello again, like so, and then run hello, now I get my row 25. like so. Then we have this idea of a loop. A loop is all about me having a chunk of code that I can use over and over again. I can repeat it. And this is based on a condition that is being checked, a true or false. So some arbitrary statement is going to be checked whether it's true or false. Let's try something. We can play a little guessing game. Let's talk about getting input. If you recall, to get input, we are using the CS50x library. So I'm going to do this using the CS50x library, and then we'll try something. So this is what we'll do. I'm going to create a variable, say the correct. Okay, I'm just going to use this to store in a correct answer. Let me not have it as a string. Let me not have it as an integer per se. Let me have it as a string. So I'm going to create a string, and then I'll say James. So what am I trying to do here? Well, I'm trying to implement a loop. So we'll create a guessing game. We'll just say guess the name, and then if they guess James, then it should tell them correct. Otherwise, it shouldn't. So it seems pretty fair. So I'm going to make use of a while loop. Keep in mind, we have two types of loops, a while loop and a for loop. So I'm going to implement this with a while loop. A while loop has a condition that is checked at each and every iteration. An iteration is a repetition. Every time I repeat the chunk of code, there's a specific condition I'm checking every time. So this is how we're going to perform the while loop. The keyword while, and then in the brackets I'm going to put in my condition. But let's hold on to that condition for now. I'm going to open my while loop. Note the opening and closing curly braces to show the chunk of code where it begins and where it ends. So here, this is my while loop. What do I want to repeat? Well, I want to ask for an answer. So this is what I'm going to propose I'm going to do. I'm going to maybe create a variable called given, but I'm not going to assign it just yet. But then when it gets here, I'm going to create a given is equals to. Alright. So every time they get it wrong, I want it to ask again. I want it to keep on asking again and again and again until they give me James. So given essentially is equal to get string. If you remember, this is the function to ask the user for a string, for words per se. Remember, if we're asking for a number, then it will be get int. If we're asking for a double, get double. I think you get the idea now. So in quotes, I'm going to put in the question that I want them to see. Guess the name per se, like so. Okay. So now in my while loop here, I'm going to put in the condition. I want this thing to repeat as long as the given, the answer that they're giving, is not equal to the correct. Seems pretty fair. So what do I mean by there's a condition that's checked every time? Well, as soon as the chunk of code begins, it will check there, and then it will come in and check there, and then it will begin by checking this. So the first time it reaches this while loop, given is not assigned and correct is James. So of course they are not equal to each other. This is true, they are not equal. Because of that, it will enter into the body of the while loop, and then it will say given is equals to getString. What does getString do? Well, it asks you for a string by showing you the text that says guess the name, and then you're going to enter something. As soon as you hit enter, it's done with the body of the while loop. It reaches there, it'll go back and check this. Is given not equal to correct? If you did not type James, it will do the same thing. Now suppose you did give it the correct one, then it will immediately break out of it. Seems pretty fair. Let's run make against hello. Now we notice that we have an issue here. Given is uninitialized, so when it gets to this line of code, it doesn't know. So I'm essentially comparing an uninitialized variable to something that is initialized. In other words, I'm comparing something with a value and something without a value, which makes no sense. So I need to give it something. Let me just give it 0 for now, as long as it's not James. If I give this the value James, then immediately it will get here and jump out because this becomes a false. Pretty fair, pretty decent. Let me clear the screen. I'm gonna run make, like so, and then I'm gonna run hello. Guess the name, Peter. Guess the name. Yes. Guess the name, quote. Guess the name, okay, fine, James. And it still doesn't. We're gonna get to this when we look at arrays. But that's the concept. This would have worked if I had integers, per se. Strings, however, they are not like that. But let's modify it a little bit to make things a whole lot better. Here, if this was an integer, what integer can I put in here? Say 1, 2, 3, 4, 5. And then given was also in turn an integer. Then this would mean that I'm not using getString per se. I'm rather using getInt, because I'm getting an integer to place into given, which is containing an integer per se. And then here I'll just set this to 0 for now. Now if I run hello, it works well. I execute hello, give me a name. I don't know why I kept it as a name, but anyways, 0, not gonna work even if I type in words. However, if I say 1, 2, 3, 4, 5, it immediately breaks out. That's the concept and idea of a while loop. Now let's try and make a countdown. If I was going to make this to countdown, how was I going to do that? So all I want to do is make this thing to count down all the way from 5 down to 0. So I'm going to create an integer. Okay, I'm going to create an integer. Let's say I want to count down from 5. So I'm going to create an integer number and initialize this to 5. So I want number to change up until it reaches 0. So I'm going to make use of a while loop, because I can see that there is a whole repetition that I'm going to do. What is it that I'm repeating? I'm repeating the whole idea of me printing out the number. So note that I'm going to need a format specifier, num. So I'm sure you can see the idea is that the first time it goes in here, it should be able to print just 5. But nonetheless, once I'm done printing out the number, what do I want to do? Well, I want to subtract 1 from the number. I print the number, I subtract 1 from it. I print the number, subtract 1 from it. But what is the reason for me to keep on repeating the whole time? I want to repeat as long as the num is less than 0. As long as my num so happens to be less than 0, then keep on repeating that whole thing. Let's run make against hello. There we go. And then if I run hello, I don't get much. Let's see. Do I? This just means that we've hit an error. This is an error. Why? Because I set this to 5. Let's see. I set it to 5. Then when it gets here, is 5 less than 0? No, and then it ends there. Remember, this has to be true in order for it to get in. So I need to flip this over to a greater than sign. As long as 5 is greater than 0, then keep repeating this. So I'm going to run make against hello. And I'm going to run hello. And then I get 5, 4, 3, 2, 1. Makes sense, but let's decorate it a little bit by having each number on a new line. So let's run make hello. And then let's run hello. We get 5, 4, 3, 2, 1. Seems fair. Seems fair. Let me clear it out. Let me do this. Now take my cursor and place it here, just where the main function begins. Then I'm going to run make hello. Then I'm going to run debug 50. Debug 50 against hello. What am I doing exactly? I'm going to show you graphically how this works. On my right, I have the debugger. It's going to go line by line. So right now, it's on this line that says int num is equals to 5. Here are the variables within my local scope. So I have the variable called num. At this point in time, it holds the number 0. See the type, it's of type integer. So I'm going to step over that line. Note now that it's 5. As soon as I'm done with that line, then it's 5. Then it gets into the while loop. Note that it's 5. Then I go in, printf %inum. What am I printing exactly? Well, it's 5, because remember, if I highlight over this, it says num is 5. So what is it printing exactly? Printing 5. And then I have a num minus minus. Note, it's 5. But as soon as I'm done with that, it goes down to 4. Because that's what this line does. Subtracts 1 from it. Takes it down to 4. Now I'm here. Well, num is greater than 0. Is num greater than 0 though? Well, num is 4. It is greater than 0, isn't it? Which is true. Because it's true, then it gets in. Printf. Print the num. What is the num here? It's 4. So it's going to print out a 4, which you'll see there. Then num minus minus, it subtracts 1 from it. Note now it's down to 3. And it goes back in check. Is num greater than 0? Well, yes, num is 3. So it will keep on going. And it prints it out. And this keeps on happening up to the point in time where we reach the point where it's 1. Now num is 1. Is 1 greater than 0 per se? Yes. Then it will print out the 1. But then when it gets to this point where it checks after performing this subtraction, num is then 0. But is 0 less than 0 though? No. Because of that, it goes to the end after the while loop. And after the while loop, there's nothing, so it pretty much ends the program there. And it closes. That's the context of a while loop. So, now that we understand a while loop, remember, it just performs a repetition as long as the condition that's placed in the brackets is true. That's the idea. So, what's the other type of loop? The other type of loop known as the for loop. The for loop is similar to a while loop. However, it has 3 parts to it. It has a beginning initialization. So, a for loop is actually commonly used to iterate, to perform a repetition based on a range, to say from this up to this, do this. That's the idea. And there is a condition, and I'm going to show you. But let's try and implement this. The very same thing. So, using a for loop, we're going to use the keyword for with brackets. And then there's 3 parts to it. So I'm going to put 3 semicolons. The first part of it is the beginning initialization. I'm going to start with the integer num being 1. I want to start with num being 1. And then this middle part is the condition and also happens to be the end. Why? Remember the while loop? We said as long as the num is greater than 5, then keep doing something. Similar here. I'm doing this as long as the num is greater than 5. Okay. And then the third part is the incrementation. What am I doing every time? Note in the previous while loop, after doing the printf, we subtracted 1 from num. We can do this here as well. Num minus minus. And then after this, I'm going to open and close my curly braces like so. What am I doing every time? Well, I'm just running printf against, well, I'm going to have a format specifier. Let's perhaps have a new line 2, comma, num. And then there, I'm going to then close it like so. Just like that. So I'm going to run make against hello. Runs well. And then I'm going to run hello. I don't get any output per se. Why is that? Well, let's trace back. So I begin by initializing this to be 1. And then I said as long as my num is greater than 5. So this has to change. Because the moment it goes in, it will check, is this very same num being 1 greater than 5? It's not. It breaks out immediately. It's actually less. So as long as my num is less than 5, in fact, I've initialized this incorrectly. If I want this to count down, I would actually want it to start with num being 5. And then each and every time, as long as num is greater than 0, then keep doing something. What am I saying? I want to start at 5, and I want to keep going as long as my num is less than 0. In fact, as long as my num is greater than 0. And every time I'm subtracting 1 from it. So, now that we perform the fix, let's run make. We don't get any errors. Let's run hello. 5, 4, 3, 2, 1. Seems pretty fair. But what is going on? So, I'm going to place the cursor right at the beginning there. And I'm going to run make hello. And then I'm going to run debug 50 against hello. Just so we can see what's going on. Note which line it's on right now. Right now it's on this line of the for loop. See the variable num? It first starts off as 0. But immediately, as soon as it goes in for the first iteration, it actually goes in with the beginning. Okay? 5. Remember, this is our starting initialization. So, num is 5. It goes in and it prints. What is num there? Well, num is 5. So, it prints 5. Then it goes back. But when it gets back, the first thing that it does is do the change. It will change the num. We said num minus minus, so it's going to subtract 1 from it. And then it will check this. After performing the subtraction, am I still greater than 0? Yes. After performing that, well, we're going down to minus 1, which is 4. Is 4 greater than 0? Yes. Then it gets in again. Note now we're sitting at 4. Then it prints it out. Then goes back up, prints it out. Goes back up, prints it out. Just like a while loop until we're done. Like so. And that's the context. That's your 2 most important loops. Seems fair, seems decent. Now, we also then have conditional statements. Conditional statements, these are just chunks of codes that we're going to be executing as long as a specific condition is true. Unlike the loops repeated as long as a condition is true. This, however, is going to do it as long as a condition is true. It's not repeating, it's just doing it once. Seems fair, seems decent, doesn't it? So let's see. How do we perform these conditional statements? So, I'm going to do this. Let's suppose I create the variable a and give it maybe the number 10. And then let's suppose I create the variable b and give it the number 20. I can try and compare to see if my a is greater than b. I want to see if a is greater than b. If this is true, then I wanted to execute this chunk of code. I wanted to just run a printf and see and tell me that a is bigger. Seems fair, seems decent, and maybe let's plot in a new line after that. Nothing big. Let's run make against hello. There we go, and then we're going to run hello. We don't get any output. Why is that, Nash? Well, note, when I'm running this code, let me remove those breakpoints. When I'm running this code, this is something to notice. I initialize a with 10, and I initialize b with 20. But let's look at this condition. A holds 10 and b holds 20. Is a greater than b? No. A holds 10. It's not greater than 20. It did not do this. Because that is false. That's why it did not run the printf statement. But if I change this rather, let's suppose I just want to check if it's less than it. I'm going to run make against hello again. And execute hello. Note now it's going to say A is bigger. In fact, I would have wanted to say, in fact, A is smaller. Just so that it works correcto. I'm going to run make against that. And then run hello. There we go. A is smaller. Makes a little bit more sense to say. I think that's much better, isn't it? Nonetheless, let's also look at this context. Look, when we're looking here, we'll realize this. We will realize that when it comes to conditional statements, they can take any of these, any of the following. You can have a conditional statement that looks somewhat like this. And if, this is literally what I have here. It's just one condition being checked. Just one if clause. Or we can have an if else. This is where we have an if and an else being one that's going to check all the other remaining stuff. For instance, here, if A is less than B, that's it. But I can have an else. Else is sort of me being saying otherwise. Otherwise, printf, I can just say, I don't know. Something like that. As long as this one is false, then immediately it will jump into the else block. Now there's a punishment for all crimes committed. Run make hello. If I run hello, it says A is smaller. But what if they were equal? What if I was testing if they were equal? And then I ran make hello. And then I ran hello. Well, most certainly it would say, I don't know. Because they aren't equal, isn't it? This is a false. Hence it jumps into the else block, like so. That's the context and the idea. That's an if else. Then we can hold an if else. This is for me to check an extra condition this time. Remember, if this one is false, it will go into the else. But this time I can add in a last resort, an extra, and say else if. Maybe I can say, oh, else if it's less than this, if it's less than instead, then perhaps run in a printf and say A is smaller, per se. Enter a new line. So, okay. This is me adding an extra condition. So if this is not true, then it will check if this one is true. Otherwise, if these two are not true, then it will jump immediately into the else block. And this takes us to the last kind. If else if. So the if else if, there's this one that has a series of else ifs. So if I want to add in an extra if statement, I can do that. I can jump in and use another else if. I can put it in. So meaning it will check this, that, and this. If all those are not true, then it jumps into the else. That's the whole sequential flow. But anyways, those shouldn't be quite a big deal. Oops. Now let me fix that. There we go. There. Last piece. Keep note of the combinational conditions. The and the or. I can use those two. The and the or. So where do I use the and? The and is used when I want both conditions to be true. Okay? This is where we use the and% symbols. Two of them. And then if I use the or, I have to perform that using the pipe. This is to check either two, which must be true. But that's enough jibby jabber. Let's look at some problems. So I've gone ahead and wrote a couple of practice problems, which I gave out some time ago. Inside my Google Drive, there should be an untitled document. I'm guessing this is the one. Seems like that isn't the one. Okay, in fact, there's the document I'm looking for. So this is it. Let's take a look at problem 1. Write a program that checks if a number is odd or even. What do we mean? Well, this is the sample output that they're expecting. It should look like this. It should ask you for the number and then tell you the number and whether it is odd or even. Let's do that. Let's propose we call this odd. Let's call this odd even dot c. So there's odd even dot c. And then we're going to begin by including our standard io.h. Okay, and then int main void. But if I look at the problem, I realize that I'm going to be getting some input here. So I may as well just include the CS50 library. Might as well do that. My CS50.h library. Like so. Okay. Now that it's like that, I'm going to do this now. I'm going to first create a variable to ask for some input. I'm going to create an int number. And this is going to be equal to what? Well, note that I'm supposed to ask them for the number. So I'm going to do that. I'm going to be using a getInt. Like so. I'm going to say enter a number. And give them some space. And note, I need the semicolon at the end. So now I have the variable called num, which should store some value that they enter. Now I need to check if it's odd or even. What do they mean by odd or even? Well, here, an even number is divisible by 2. An odd number is not divisible by 2. So let's just check if it is odd. So if a number is, okay, in fact, let's check if it's even, rather. So if it's even, it should be divisible by 2. So I'm essentially checking if num is divisible by 2. And to check if something is divisible by 2, we're going to use the modulus. And the modulus makes use of the percent symbol. %2. What did I just do? Well, I'm taking num and dividing it by 2. And then this is going to throw me back the remainder. And I want this to be 0. So what am I really saying? I'm saying if num divided by 2's remainder is 0, then do something. What is that something that I want to do? Let's do that. Oops. Well, the thing that I would like to do is throw in a printf. Now let's look at the format. You should first print out the number and is even. So the number and is even, like so. Then I'm going to throw in the number itself there, like so. And then of course, if this is not true, then it's obvious that it has to be odd, isn't it? So I'm going to throw in an else there. Or else, I'm going to throw in my printf. And then the number and is odd. And then my format specifier should be able to catch the number itself. Let's try it. We're going to make odd even. And we should be, there we go, we get the output there. So if I run odd even, like so, and I enter the number 10, I should be able to get an is even. Now of course it doesn't look as good unless I, of course, place in a new line like so. Now that makes things a whole lot better. So if I run make odd even and run, and then immediately run odd even and give it the number 10, it should look a whole lot decorated. Let's try the next problem. Write a problem that calculates the sum of the first 100 natural numbers. So it should tell me that this is 1050. So all natural numbers, what do I mean? We mean all the way from 10. All the way from 1 per se, 1 up to 100. It has to add up all of them and then throw us the answer to that. So I'm going to be realizing that I'm using a loop here. So let me do that. Let me propose I'm going to touch another file, and then I'm going to call this sum100. Yeah, let me propose I call it sum100. So if this is sum100, I'm going to have to add the dot c to the end. So I'm going to add the c to the end of it. Then this creates sum100. So you of course know how we begin this. We're going to begin by including the standard io.h. Now I'm not going to be getting any input, so I'm not going to include the CS50 library, but I'm going to jump straight into the int main void, like so. Now this is what I'm going to do. I'm going to create a variable to keep track of which number I'm on. So I'm going to actually make it start from 1. And then I'm going to create another variable called sum to keep track of everything that I'm adding on. And I want this to begin its count at 0. Then I'm going to make use of a while loop here. Of course, you can use a for loop. I'm going to show you how it looks with a for loop, but I'm going to use a while loop instead. I'm going to put the condition last. But essentially what I'm doing here is I'm going to be taking sum, and I'm going to be adding on the I, which is the number that's transversing up to 100. Now what condition am I really using here? Well, as long as the number that I'm at, the I, is not yet equal to 100, then I need to keep doing this. What am I doing exactly? Well, I'm adding the I itself to sum. Then, as soon as I'm done with this entire while loop, then what I need to do is run printf and print out the number. So I'm going to make use of a format specifier integer, and then maybe we might need a new line there. And then what am I putting into that place? Well, I'm printing out the sum, so that's the idea. So I'm going to save this, and then run make against sum100 times fair, run sum100, and it takes a while. And it's still running. We've hit an issue. It should have not taken so long. The reason for that is the I is not changing. So as soon as it's done adding the I to it, it should go to the next I. It should add 1 to the I, like so. Then if I run make hello, or rather make sum100, and then run the sum100, then we actually get a number, like so. So this is me adding the first 100 numbers. I don't know why I would have gotten a 50-50, but nonetheless. Then the last problem is looking quite similar to a Mario problem. So it has to print this pattern. This is a Mario problem. It's printing hashes of a specific height, per se. What am I talking about? Well, look at this. We're having a triangle of height 1, 2, 3, 4, 5. It's a triangle of height 5. So this, in fact, uses loops. So I'm having a loop that's going through the lines, and I'm having a loop that's printing the hashes. So this is it. So let's propose this is touch Mario dot C. So here's my Mario start. So in this problem, it has to be the 5 because that's literally what I'm given. Okay. So I'm gonna start off by including my standard io.h library, and then I'm gonna have an int main void, like so. Then I'm going to create my variable. So in fact, let me not create a variable per se. Let me jump straight to the for loop. So I said there's a for loop that's going to say for every line print hashes. I'm trying to put this problem into pseudocode. So for every line, print hashes for every line. I don't know if that makes sense. So let me try and comment this idea out. So I'm just gonna do this. This is just me putting comments in my code. This is just a guideline. So I'm saying for every line, print hashes for that line. This problem being in pseudocode actually helps me to see the fact that this is a nested for loop. I have a for there and I have a for there. So how do I go into every line? Well, note that I'm transversing all the way from line number 1 up to line number 5. I'm gonna do that. So I'm gonna create my for loop. Note for the first part of it is the start. I'm starting for the integer row being equal to 1. I could have called this variable anything than row, but row makes me understand what the variable. I want to start from row being 1, and then I want to keep going as long as the row is less than 5. Seems fair. And each and every time I'm going to be going to the next row, so I'm adding 1 to my row number. Then what am I doing in each and every row? Well, I'm going to have another for loop for each and every row. And note that the row number for each row is actually the number of hashes that are onto that row. This is pretty mathematical. So the row number is telling us how many hashes there are. Row number 1 having 1 hash, row number 2 having 2, 3 having 3, and so on and so forth. Seems fair, seems decent. So this is me saying my hashes. So I want to start printing from the first hash. So note now that I actually have to start from the integer, hashes being 0. So I'm starting from hash 0. And I'm going to keep going as long as the hashes that I've printed are less than the row number. And what am I doing every time? Well, I'm going to print the next hash. So I'm adding 1 to the hashes. And what am I doing essentially? Well, I'm running printf of printing literally a hash. And that's what the line does. But all this chunk of code is going to run for each and every line, but this for loop just prints out the hash. But as soon as it's done printing out the hash, I wanted to print out a new line before going to the next row. So I wanted to print out a new line. So this is what I'm saying. So the inner for loop is actually going to do for this line. But as soon as it's done, I wanted to incorporate a new line so that it starts printing the next row for the next row. That's the idea. So then I'm going to go close that off too, like so. Then I'm going to run make against, not hello per se, but rather Mario start. And then I'm going to run Mario start. But this seems to have issues, doesn't it? This seems to have issues. Perhaps you're thinking, I should run it again. Then here, Mario start. I'm just getting a row of height 3. This is not per se what I want. So to fix this, I'm going to use the equality sign so that it actually ends at where the row is equal to 5, not 4. Also the hashes, I also wanted to include the actual row number. If I save this and clear that out and run make against Mario again, and then I'm going to run Mario dot, I actually get the height 5. 1, 2, 3, 4, 5. And it looks pretty fair and pretty decent. And that is it with the beginning part of C. Give it some practice for each of the problems, and we'll see each other in this coming week. See ya.